Okay, we're going to start with a little bit of the homework, some solutions to the homework from page 458, the review of vectors. So number 33 out of the textbook is asking for you to find the component form and the magnitude of vector v. So we're going to say that this is vector v. In component form looks like the change in x and the change in y, which is critical that you start by saying the end coordinate minus the start coordinate. So we're going to end with the terminal coordinate of 7, 3. So we'll say a vector, which has that pointiness to it, is 7 minus 0. Comma the y's will be 3 minus 10. So our components for vector v will be 7, negative 7. So that's one of the answers they wanted. Then they also wanted the magnitude. Magnitude is written like a double absolute value symbol. That's really called magnitude. And magnitude is the length. How long is this vector? And if we have the components already, so even though they told me the coordinates, I'm going to ignore those and I'm going to look to my components. If I have components, then I can say I'm going to square the change in x plus square the change in y. And so our magnitude, or our length, is going to be the square root of 49 plus 49, which is 98. And then if you're using my calculators, you don't have to work hard. If you're using a graphing calculator, you either need to get a program that will do this for you, or you'll have to simplify it in your head to 7 root 2. So how I do that is I look at a square number, which is 49 times 2 makes 98. The square root of 49 is going to come out as 7. And then you can't take the square root of 2, so we'll leave that in. That's if you have to do it in your head. Otherwise, you can just press that on your calculator and you get that. So that's our magnitude, or our length, of vector v. Alright, and now we're going to be taking u and v and doing some operations to them. So the first one is just add them together. So they're in component form. I know that because of the pointiness here, and the fact that they told me that these were vectors and not points. So I'll take -1 and add that to -3, and I'll do the y's, -3, and add that to 6. So these are my x's, it changes in x, and it changes in y. Now we're going to add these together. That's why there's a plus. So I get a -4. Add these together. That's why there's a plus. And I get a 3. So the intent for drawing in our class is you would draw them separately. You'd start here. So I'm going to be going left, which means I'd like to start up here. I'm going to go left 1 and down 3. That's what U would look like. Then I'm going to go left 3 and up 6. These are not perfectly to scale. That's V. So where did my very beginning part, I started way back here. I'm going to start my answer vector right at the very beginning and go to where I finished here. So there's my resultant, and that would be u plus v. So I did all of that without even looking at these numbers, but that should match up. So if I start here, sure enough, if I go left and I go up, I'll be going where that resultant vector is. So u is a -1, -3. And negative v is going to be the opposite of what we have here. So I'm going to say I have a +3, +3, and a -6. So in order to put those together, I will get -1 plus 3 and -3 plus -6, which gives me 2, -9. So I'm going to graph, starting with these. So if I graph u, I'm going to come here. Be the same as I did originally here. But now the difference is I'm going to do the opposite of v. So instead of going in this direction, I'm going to be going to the right 3 and down 6. That's what the opposite of v looks like. So we'll call that -v, +u. So again, where did I actually begin this whole process? It was here. So I'm going to come from the beginning to the end. And that should be u minus v. Let's double check what we got here. Sure enough, we went to the right and we went down. So that looks like it matches. And so 3 times u would be -1 and -3 is the same thing as saying -3, -9. So if I started u here and I did 1 of them, 2 of them, and 3 of them, that would be the same thing as if I started back here at the very beginning. And I'm going to start at that dot, and I'm going to go 3 to the left and 9 down. So that would be in the same exact spot. So either way, we have u, 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 or 3u. And then I have 2 times v, which is -3, 6, plus 5 times u, which is -1, -3. So that's 2 times -3 is -6, and 2 times 6 is 12, plus -5, -15. So adding those together, I get a -11 and a -3. So how we're supposed to draw that is going to be a little tight in here. If I start, I think I can start here. So I'm going to go, I'm going to have to start a little higher. Hold on. Okay, let's start here. So I'm going to go -3, +6, that's 1v, but there's 2 of them, so I have to do 2 of them. And then I'm supposed to do 5, that's where it's going to be rough. Negative and down, negative and down. These aren't going to be perfectly to scale. 1, 2, 3, 4, 5. So that's a V, a V, a U, a U, and a U. So here is my beginning. And then I would start there. And go towards my final ending. And I'm supposed to have gone left and down, which looks like that's what I did. So that's a 2V plus a 5U. And the other ones all have to do with the optional information, so I'm not going to include that in this video, but they had to do with I's and J's, and they have to do with dot products, so I'm not going to require that on the test.